Beginning with section 5.1, we start doing more business type calculations. And a lot of the focus for this is on interest that is either paid or interest that is owed. So we're just going to start with our first lesson. 5.1 is simple interest and discount. And we're going to begin, as we usually do, with some definitions. Our first definition is interest. Interest is defined as the fee paid to use someone else's money. Now, this someone else could be a bank, could be a person. Anytime someone charges you a fee to borrow their money, you're talking about interest. There are several types of interest. Simple interest is one of them. This is interest paid only on the amount borrowed. Or invested. And not on the past interest. A little bit later, we'll talk about the type of interest that is built on the amount borrowed and the past interest. You'll need to know what principal is. This is the amount borrowed or deposited. Typically, this is indicated with a capital P in formulas. And then we have the rate of interest or interest rate that is given as a percent per year. And expressed as a decimal. In formulas, that's typically a lowercase r. And then our final definition is the definition for time. The time variable that's in our formulas will represent how long the money earns interest. In years. So if you're given a time measurement that's something besides years, I'll show you how to account for that and translate it into a year time frame. Okay, we're going to jump right into our word problems here. With a formula, you'll need to know the simple interest calculation. The formula for that is capital I for interest equals P for principal times R for the rate times T for time. As we go through module 3, you're going to rely really heavily on this formula chart that you can find in the folder. Particularly for today's lesson, we're talking about simple interest. You don't necessarily need those formulas memorized. You just need to know where to find them and how to use them. Okay, problem number 1. Logan borrows $42,000 from C-Force Loans, which is owned by Chuck Norris, to pay for the first year of college at Texas A&M. Mr. Norris charges 3% interest on the 10-month loan. How much interest is paid? So if we go piece by piece through the information, first of all, it says Logan borrows $42,000. That would be the principal, the amount borrowed. He charges 3% interest, so the rate is 3%, which we need to translate to a decimal by moving the decimal 2 places left or dividing by 100, so 0.03. And the time is reported to be 10 months. Our time measurement must be in years. So since there are 12 months in a year, it would be 10 divided by 12 years to give you that fraction of a year. And you could go ahead and divide that or simplify the fraction. Or you can simply plug into the formula 42,000 times 0.03 times 10/12. Calculate that and you get $1,050. So in addition to the 42,000 being paid back, Logan would owe another $1,050 in interest. So a note here, simple interest is normally used for loans with a term of 1 year or less. Corporate bonds are an exception. Paying simple interest twice a year. For a specific length of time. Okay, problem number 2 says that Amazon.com Corporation issued 5-year bonds at an annual simple interest rate of 1.2% with interest paid in semi-annual payments. Warren Buffett buys a $6,500 bond. So first question is, how much interest will be earned every 6 months? So that twice a year pattern. They have a principal of $6,500 with the rate of 1.2%. In decimal form is 0.012. And since the interest is paid in semi-annual payments, that is every 6 months. So for time, you could say 6/12, 6 months out of a year. So the interest that's earned every 6 months, we do 6,500 times 0.1012 times 6/12 and get 39. So $39 would be the amount paid every 6 months. So part B asks how much interest will be earned over the entire life of the bond. The interest for the entire life of the bond would be 6,500 times 0.012 times 5. This gives you $390. Now that could be calculated by taking the 39, doubling it for twice a year, and then multiplying times 5 to get the total for 10 payments. Or you can do as we did here, principal times interest times the time frame of 5 years in this case. So throughout this discussion about interest and things, we'll talk about something called the future value. Or you can also think of this as the maturity value. That will be indicated as capital F, capital V in our formulas. And the future value of any P dollars, principal amount of dollars, over a time of T years at the interest rate R per year is calculated by future value equals P plus I. So P being the principal, I, if you think about the formula we just learned, is P times R times T. So sometimes you'll also see the future value written as P factored out times 1 plus RT. So you can see on the formula charts, various ways that the future value is written in a formula, and you just use which one is more appropriate for your problem. So problem number 3 says Hyde borrows $20,000 from his parents at 5.25% to add a Houston Texans themed man cave onto his house. He expects to repay the loan in 9 months with a bonus he will receive from work. Find the maturity value and amount of interest paid. So the amount borrowed by Hyde, the principal, is $20,000. The interest rate he's paying is 5.25%. or 0.0525. And the amount of time he's given himself to pay it back is 9 months. So 9 divided by 12. It asks us for the maturity value. That means the future value. So the future value of this loan, I'm going to use the P times 1 plus RT because I have the values for P, R, and T. P is 20,000. And then 1 plus 0.0525 times 9/12. If you calculate that, you'll get 20,787.50. And that would be the amount he would pay back in maturity. And then it asks us to find the amount of interest paid. So while this is the maturity value, the interest is the difference between the future value and the principal. So basically, how much more than the principal does he pay? So future value minus the principal of 20,000, $787.50 is what he paid in interest. Number 4, suppose you borrow $15,000, that's our principal, and are required to pay $15,315 in 4 months. So that's actually giving you the future value with a time of 4 months, so 4 divided by 12 to pay off a loan. We can use that information to calculate what our simple interest rate is. So this is manipulating our formula a little bit to find a different value. So our future value formula, P times 1 plus RT. I have the future value. I have the principal. I have 1 plus R, I don't know. T is 4/12. So we need to just solve the equation from there. So with the parentheses, I could choose to distribute that value. But since I'm solving for R and R is inside of our parentheses, I'm actually going to divide by the 15,000 up front first. So that gives me 1.021 equals 1 plus R times 1/3, simplifying that fraction of 4/12. Then I can subtract 1 from both sides. And then to get rid of that 1/3, multiply by 3/1 on both sides. And that gives me an R value of 0.063. We typically report percentages for interest rates. So moving the decimal to the right this time, since I'm going back to percent, would be 6.3%. Okay, so we talked about future value. There's also a thing called present value. Present value you'll see in your formulas as PV, or the letter we've already used, just capital P. This is the amount of money that can be deposited today to yield some larger amount in the future. So this would be used if you have some kind of financial goal. Like on the problem about the man cave, if he had decided to save for his remodel instead of borrowing the money. You think about your present value. So present value is equal to the future value divided by 1 plus RT. And that's just a manipulation of our future value formula. Again, remember PV is the amount at the beginning of a loan or savings. FV is the amount at the end. So before we go into our last word problem, just to give you an example, you could be asked to find the present value of $100,000 in 37 days at 8% interest. So present value is what we're looking for. Future value is what we know. We need in 37 days to have $100,000 using an interest rate of 0.08 times 37 days. Anytime you're using days, assume 365 days in a year. So from our present value formula, we would do 100,000 divided by 1 plus 0.08 times 37 over 365. That calculation would be 99,195.56. So if you had some bank account where you could put money at 8% interest and leave it for 37 days, this is the amount you would deposit. And by the end of the 37 days, it would be matured to 100,000. Okay, you'll see two types of loans referred to with these problems. First is a simple discount loan. This is a loan where the interest is deducted in advance. From the amount of the loan. And the balance is given to the borrower. The full value must be paid at maturity. Okay. And then we'll talk about as well selling US Treasury bills, which are also known as T-bills. This is one way the US government makes money. T-bills are purchased at a price less than face value. Or at a discount, as we talked about the discount loan above. And when they mature, the government pays the holder full face value. So for example, you may buy a treasury bill for $100 and then in 18 years, it'll be worth $250, but you only paid $100 for it. You just have to wait for it to be worth its value. All right, number 5, an investor who is known by many to be a money tycoon bought a 6-month, $10,000 US Treasury bill on July 14th, 2016 that sold for a discount of 0.39%. What is the amount of the discount and the price of the bill? So the discount is calculated by doing the present value times rate times time. So it's worth 10,000. The rate is 0.39%, so that'd be 0.0039. And then it is a 6-month bill, so 6 divided by 12 for time. That calculates to be $19.50 is how much is discounted. So that means the price is the face value minus the discount. So in this case, 10,000 minus $19.50. So 99.80.50. So that one's not necessarily a great discount, but that's because of the short time frame. The longer the time frame, typically the better the discount is. All right, last one. Find the actual interest rate paid by the Treasury. So to calculate this part, we use the future value formula. The future value being 10,000. Present value being what was paid as the discount, so 99.80.50. And then 1 plus R times 6/12. And we're going to figure out what this actual rate is. So we had the discount rate here. So the R in the formula for part A is not the same as the R in part B. So similar to the way I solved before, I'm going to divide by this 99.80.50. And then this would be 1 plus R times 1/2. I simplify, subtracting 1 from both sides. And then to get rid of that 1/2, multiply by 2/1. And I get a rate of 0.0039076 or 0.39076%. So those percentages are very close together. So one additional note on your homework, if you have a time frame that talks about, like, say something from March 15th to April 18th, you're going to calculate this using days. And you'll use your typical days of the month. So September, April, June, and November have 30 days. The rest have 31. So you would consider March as having 31 days. So you would go from March 15th to 31st, and then April 1st to 18th, and count the number of days to do a calculation if you're given a time frame such as this. And I believe this is on problem number 3 in your assignment.